Okay, let's get started. Good morning, everyone. My name is Rob Zuber. I'm the CTO of CircleCI. Thank you so much for joining us here this morning, or this afternoon, or this evening, depending on where you are. It's a great pleasure to have with me today Nate Taggert, who's the CEO of Stackery, a new friend of mine. I've had a chance already to learn quite a few things about serverless from him. And wanted to take the opportunity to share that with all of you. Nate, do you want to take a second just to introduce yourself?
Yeah, thanks very much. So happy to be here with you. I'm Nate Taggert, CEO of Stackery. So Stackery is a serverless operations console, and we help enterprise and developer teams build serverless applications together. Our entire backend is driven on AWS Lambda, and we've been working exclusively with serverless for about 2 years now. So a lot to share.
Very cool, very cool. Thank you for that. I guess I should tell people what CircleCI does too. Hopefully many people know since we invited a lot of you, but we're obviously a small step before Stackery in terms of your developer flow, focusing on helping developers get their product out into market faster and with higher quality through continuous integration, continuous delivery and deployment, both hosted and server installed if you want to run it yourself. So awesome. Well, with that, as I said, Nate is like in the world of serverless, an expert, someone who's been around for 2 years. For many of us, I think serverless is in one of these states where we're hearing about it, and a lot of people are talking about it, and at the same time, we're thinking, should I be doing something with that? I don't even really understand what it is. I personally have been in this industry long enough to have installed many servers and data centers. I'm pretty sure there has to be a server under there somewhere. What does all this mean to me? So maybe to help everybody out, you could just give a quick overview for all of us of what it really means to be serverless, and how people should just frame it in their heads in terms of thinking about it.
Totally. So I think the best place to start is just to acknowledge that serverless is the world's dumbest name. There are servers. Your code's going to run on servers. The idea here, and AWS has a really great phrase for this. Amazon talks about how you get to outsource with serverless. You outsource the undifferentiated heavy lifting of managing servers. So the idea here is you focus on your application, you ship your code to the cloud provider. All the major cloud providers have a serverless solution, and they handle the scaling, they handle the availability, they handle the orchestration. You focus on application development and delivery.
That sounds great, and I love that you use that expression, undifferentiated heavy lifting, because I think everyone in our space uses it. I mean, we talk about the same thing for CI and CD. This is not what you're building. This is not the goal of your product. Go focus on your product, and we'll take care of that piece too. So that definitely resonates with me, and I'm sure will resonate with many folks who are listening. As we just before we continue, I realized I forgot to call out at the beginning that there is an opportunity for Q&A at the end, and there's a little Q&A. You should see a little Q&A icon if you want to ask questions. You can post them in there at any time, and we'll get to them at the end. Great. So maybe based on that, one of the challenges that I think that comes up for a lot of people is okay, so I kind of have a sense of what that is, and I would love to not have to manage my servers, but I manage a bunch of servers. What are some really key or obvious places for people to start getting into serverless? What are applications that fit really well, maybe are the easier ones to model in a serverless world that people should think about maybe testing out?
Yeah, so there's a pretty consistent pattern that we see with every single company that we work with, where they start with low visibility and low criticality workloads, and they start kind of testing the waters with serverless. And that's almost always a background task of some sort. So think about something like a cron job. You've got some script that runs, once a night, once a week, and it's sitting on an EC2 instance or something, some kind of server, 24 hours a day that you're paying for, so that it can run on demand. And this is a great entry point for doing your first serverless application. You take your script, chances are your programming language that it's written in will work just fine on serverless. There's a lot of kind of growing support. And you hook it up to some timer, some cloud event, a CloudWatch alarm or metric that you can listen for, and it'll trigger your workload. And so now what'll happen is your serverless application, your function will start on demand. You'll pay for the few seconds or the few minutes that it's running. It'll shut off and be done, and you're not paying for the rest of the time. But it's also, the cost savings, I think, is what people point to a lot. But the real advantage here is not having to manage the infrastructure that these little services are running on, right? We typically see people start there, and then they start to build, I think, kind of higher visibility, more mission critical applications. And typically the path forward is using serverless applications to back an API, or as part of your microservices pattern. So rather than say, we're gonna rebuild our whole application so that it can run on serverless, you can take little components and say, this piece of the application will migrate to serverless. It'll be easier for us to maintain, or we can move more quickly.
Got it. So you mentioned a really interesting, or you made an interesting statement in there, specifically mentioning functions. And, AWS very famously called serverless Lambda, and you talked about using Lambda in your infrastructure. For those who don't know, CircleCI is a closure shop, so we think a lot in functional programming. But you also talked about these very short-lived, I'm running a cron job and I'm doing it once a day kind of thing. So then there's a mental leap in there that I think is interesting and probably a blocker for people when they conceptualize using serverless. So you talk about, okay, next step, we're going to build out an API, but I don't think of my API necessarily as a function, right? It's long-lived, it's always listening, it's not running on a cron job. So how do those two worlds come together in that way? Like, what is the mental connection that people need to make to think about serverless for APIs?
Yeah, for sure. So I think this is part of what gets confusing, why serverless feels a little tricky to conceptualize, is we're overloading a bunch of these words. So AWS calls it Lambda, which has this kind of implied functional programming paradigm. If you're not using the phrase serverless, you might be hearing functions as a service, FaaS. Which, again, we're talking about functions in a few different ways here. So you have your code, right? Your building blocks, your little components. You've written a code function, and now we're going to want to run that on demand. Certainly, that's not terribly confusing. But what gets a little tricky is that these ephemeral compute instances, AWS Lambda, Azure Functions, can encapsulate more code than a single literal code block, right? So what you can do is you can build an application and then run on that application on demand. At a very basic level, we can map this one-to-one. We can make this very easy. We can say we have an API. When it gets hit, it's going to trigger this code block to run. That's my function. It's function as a service, right? But we can also get more sophisticated, where we can build an entire application, ship it into Lambda or Azure Function or whatever compute instance we want to use, and then say, when my API endpoint gets hit, I'm going to take that transaction, I'm going to route it through my application, just like I would with like a long-lived server application, and then I'm going to select the right code block to run within my code. So when we're talking about functions as a service or serverless, I think of it more as this ephemeral compute instance. Compute that's a managed service. It spins up, it runs, it dies off. Instead of thinking of it in terms of like functional programming or how small your code needs to be for this to work. Right.
That's great. Well, I think that's one of the most common misconceptions, I would say, about serverless. I'm sure you've heard more of them than I have, or maybe I forget which ones are misconceptions because I think they're true. So based on your last couple of years' experience, what else do people think about serverless that doesn't quite line up with what you're offering?
Yeah, so serverless, first off, it's high in the hype cycle right now. We're hearing a lot of buzz. There's a lot of positive mentions, and I think as people start to embrace it, they run across, I don't want to say problems, but challenges that are pretty predictable. One of the biggest ones that we hear a lot about is that serverless is no ops. Like, you don't have to manage anything infrastructure side. And that's patently untrue. There are certainly some ops responsibilities that you get to outsource. So you no longer have to manage orchestration for this application. Things like availability, load balancing, scaling. These are the things that are happening under the covers as part of the managed service that is your serverless application. But serverless is really, when we talk about it in the functions as a service way, we're really talking about compute. And that's it. Mm-hmm. And no real application is being built with only compute. You're going to have some kind of trigger for the application, an API endpoint or something, an event stream that you're listening on. You're going to have dependencies, third-party services, internal services, data stores. You're going to have networking needs. You want to put this inside of a VPC or something. And all of those pieces are pieces that you still have to manage. And this is, I think, where serverless actually gets tricky for people, is they say, awesome, I can focus on my code. I can dramatically improve the velocity of delivering the software. And then they write their application, they go to ship it, and they realize there's all these building blocks and components that they still have to cobble together and assemble. So I'd say that's the big one. One more that I'd call out is the development model changes a little bit for serverless. So I'm sure we're all used to the pattern. I write code on my laptop. I test it on my laptop. I can run like a little, development environment locally. And then when I'm satisfied, I'll PR it and we'll release it out to like a staging environment or something. And the challenge is you can run your functions locally, of course. Your code will execute locally. But again, it's only the code. So if you're connecting your Lambda or your Azure function to these other resources, then what you're going to need to do is find a way to replicate how those other services are working. And since you can't run all of AWS on your laptop, the reality is that the ideal development cycle for serverless is going to involve a lot of very frequent pushes to the cloud and testing and running the application in some kind of development environment, but in the cloud. So you want each of your developers to be able to stand up an instance of the app, isolate it from the others, be able to work with it in a production-like environment to really drive resiliency in your application. And that's a learning curve that a lot of companies, I think, struggle with as they start to embrace it at a bigger scale, right?
Yeah, that's very interesting. It's very topical for us, even outside of serverless. And so I'm going to guess others have gone through this. I've seen solutions coming out from just a microservices model, where suddenly instead of one, monolith that I can run in a low footprint environment, I have 20 or more and hundreds in some people's environments, right? And so figuring out either I only actually need these ones to do development and test, or I need some way to spin all this up and have it running locally and disregard, okay, it gets worse or more interesting, if I've used Dynamo or something that doesn't have, or SQS that doesn't necessarily have a local version, right? Something that I can talk to in a local test environment. So I think there's a lot of complexity around that in many of these solutions that we're trying to evolve to, right? The more we outsource a lot of this stuff into the cloud and get that, we get the upswing in velocity from an operational perspective, we have some challenges in other places, right? So I think we have a long history in software development of just finding new problems to have for ourselves, but all in the name of advancement, which is usually pretty exciting.
For sure. It's interesting because, I was talking to a big, name brand, Fortune 500 enterprise about their development cycle. They're moving into microservices, and they were telling me that the challenge that they have is one of their applications is composed of 25 microservices. They have 20 people on the team, and each one of those developers has to stand up an instance of the application, which means that 24 hours a day, they have running like several hundred, 700 plus servers just for the development cycle. And I don't think that cost is the real benefit. Like it's not the biggest win you'll get with serverless, but it's significant. I mean, when you're thinking about just to develop an application, you need 700 servers running versus pay on demand down to the millisecond for what you actually consume. It can be really dramatic.
Mm-hmm. Hmm. Yeah, well, I think that'll be an interesting and evolving space for sure. I wanted to go back to something you mentioned a little bit earlier with respect to the misconception that serverless is the absence of operations, right? You give up this whole thing. I was going to call it no ops, but then that's means something else. So, tell me a little bit about some of the operational details. So, you know, we are operating at a fairly large scale. We have an SRE team, like many people that look like us. As I described, we have a microservices environment. And so there's lots of things that come with that, right? Like managing isolation of different services, what the network looks like, which services are allowed to talk to which, how you authenticate connections between them, that kind of thing. And I'm curious, well, let's just start with that one. I'm curious what that looks like in a serverless environment. How do you think about authentication between systems, even communication between systems?
Yeah, so this is really key. This is a big change, and I think it requires kind of a new model, a new way of approaching the problem to really do this well with serverless. So let me give you kind of the naive approach first. So you build your first Lambda. Let's say you're doing it in your own AWS account. You're doing it at home. It's a side project, and you realize like this Lambda has to talk to all these other services in your account. So you have one of two things. Either you pour over the IAM docs and you figure out exactly how to like turn on the right permissions, turn off all the others, right? And you dial it in and you release it. Or you do the thing that everyone does, which is you go Google it and you find, how do I make it so it can connect to everything in my account? And this is like the worst anti-pattern ever, but every single tutorial that you'll find will show you basically how to turn on Lambda to talk to everything. Now, if you're working on a blog, a side project, whatever, like I'm not encouraging you to do that, but whatever, it's a path forward. But like, there's no way you can bring that to work. There's no way that your model at work is all of my Lambdas can do anything globally inside of AWS, right? And what's more, in order for you to configure the roles and permissions for that Lambda, you have to have permission. Your user has to have permission to define what those roles are. You have to have godlike permission in the AWS account and be able to apply that to all of your resources. And this just isn't going to work, right? So then we start to get a little more sophisticated. We say, all right, well, the old ops model that we have, we define our architecture, we give it to an architect who reviews it and then creates the right IAM policies. And once they're created, we can apply that to our resources. That works super well when you have long-lived, kind of stateful resources. But when you have this very short-lived, ephemeral kind of dynamic architecture, like you can't, every time you go to change your functions, you can't wait for an architecture review. I mean, that is not going to drive velocity. So the new model, kind of the leading practice, and we're really just starting to see this kind of take hold in the market, is that companies are instead using tools, and Stackery is one of them, where you can define what your policies are. How do you manage roles and permissions? And then have this, this framework or this tool actually go apply those for you dynamically. So I change my architecture a little bit. I add a new function. I hit release. I need that new function to be locked down to only the resources it's supposed to talk to. But I want that to happen on the fly. I want that to be at deployment. That right policy gets created and applied, and I don't have to stop my development cycle to get an architect to like manually do that. And it's this kind of automation where, and I'm sure any CircleCI customer is used to this idea. Automating as much of this as possible, that creates consistency, it creates standardization, it improves resiliency, removes risk of human error. And we've gotten really comfortable with that in a lot of domains. And I think, roles and permissions are the next domain where we start to apply that.
Got it. Got it. That's really cool. Yeah, I mean, again, it's one of these things that however people are evolving, I mean, if you're just kind of getting into microservices right now, you have similar questions, right? Things have gotten a lot more complex very quickly. And having a good strategy is probably better than the we'll just open up all the ports and get on with our day sort of strategy, which I know has been the result for some people. So similarly, before I move off the operational side, you know, if I have a team that's still ultimately responsible for this thing, they're gonna want to know what's going on. Are things working effectively? So tell me about monitoring in this world and alerting. I mean, just what does that whole world look like? How do you know that things are doing what's expected?
Totally. It's changing, and there are some new patterns that you're going to want to think about. At a kind of easy entry point level, Lambdas, when they run, they're automatically configured to collect certain metrics, ship them into CloudWatch. They'll log out when they run. And you get some kind of basic level error visibility. So if you throw an exception, it'll log the error message, it'll give a stack trace. And you get that out of the box. So like, you know, from a starting point, that's not bad. But the thing that I think is really different that people are trying to adapt to is that these compute instances, because they're ephemeral, you don't really have a way to go in and inspect them after the fact. So you have to collect any meaningful data you want, any debug information, anything about performance, state at runtime. You have to collect that at runtime. So this process of monitoring, which I think historically you could have looked at kind of retrospectively, right? You could have an ops team, they say, we've detected a problem, we're gonna go investigate what's causing that problem. Now that is part of the development cycle. Developers have to instrument their application in advance, because when it runs, you know, that it'll spin up this function, it'll execute, and then it'll shut down. And any data that was alive in that compute instance is gone forever now. I think this is a big shift, but it doesn't mean that it's super, super hard either. So the pattern that we've embraced at our team, my co-founder and I, we came out of New Relic. So we're using kind of a New Relic-like approach, which is we build the function, and that function has an entry point. It's called a handler, right? Where basically it's going to say, when this event happens, an API request gets made, call this function, right? And what we do is then we've introduced what we call function wrapper. You can kind of think of this as like a decorator pattern, where you say, I have this generic handler that's going to call my real code. So every function is actually calling the generic handler first. We run the real code that you want to execute within a try except logic loop, so that if you throw any errors, if you have any problems, you still have a runtime that you can collect diagnostics out of. And by doing this, you can actually, I think, it's a pretty easy pattern. It doesn't rely on everybody manually instrumenting every function, which is, that's a recipe for disaster. But it still gives you kind of this high visibility, high fidelity way of getting the meaningful information you need out of the application.
Yeah, that makes a ton of sense. We use that same pattern and have from days of monolith to now in services. And it's interesting, I had a little bit of course that's what you do in my head, but then I wonder if that is a functional thing versus like the way that you might do that in an object-oriented world would be a little bit different. But well, with first-class functions, wrapping them in other functions is a big part of how we think. And the other thing that I think is really interesting about that description, we talked a little bit earlier about how we create new problems for ourselves with the new approaches that we take. But I've been saying, I think since cloud, like when I first started using AWS, for sure, it was kind of this, well, and based on the way that AWS worked at the time, machines are going to go away, and we should build assuming that machines are going to go away. But they were always going to go away. Like the physical boxes that we had in data centers in the late 90s, they broke too, right? This is just someone else's box breaking, and they actually have better tooling than we ever did. And so in a lot of these cases, it feels like we are forcing ourselves to build the software we always should have built. Like the notion that I'm not going to instrument my code, and if something goes wrong, we'll just go dig into it later, is a great way to cut some corners, but it's not a great way to think about, scalable systems, right? And so there are some nice side effects where we're effectively forced because it becomes so much more obvious to us how important these approaches are. We're forced to adopt them sooner, and I think it's a weird thing to cause yourself some pain so that you go solve it, but I think it's like in the mantra of most DevOps descriptions, right? Like, if it's horrible, do it as often as possible until it stops being horrible. And so I think that a lot of the models you're describing are actually good models that are approaches that work in even in non-serverless environments.
Yeah, I mean, and you're using, as an example, you're using instrumentation. I think that's a good example, but the same's true kind of all through the development cycle. Again, you can't replicate the cloud on your laptop, so you're forced to use the cloud as a development environment. And while there might be some initial pain in like how that slows the cycle and learning how to create a fast deployment loop, the reality is now you're executing your development in a production-like environment, and that's certainly a step closer to ideal.
Yeah.
So I think we see this pattern over and over where serverless really is driving a lot of leading practices in what we should be doing and maybe should have been doing all along.
Absolutely. Cool. So covering a little bit from a personal angle, as you get to scale, so in a lot of these cases, we talk about little small projects and stuff like that. We're a, I think, relatively sophisticated operational shop. We're already, as I've talked about, going down the path of services. We use Kubernetes to manage those services, orchestration and a lot of the pieces that you've talked about. I would say we understand. Everybody can be better at these things, but we understand them and we've invested in them. So is there something different that we would think about in terms of where this might be valuable to us, or changes that we might make in the way we think about software deployment, given our profile?
Yeah, so I think there is. I think there's something interesting here that we can tease out, which is kind of who should be thinking about serverless, who should be betting on it, who should be investing in it. And then kind of adjacent to that are like, what are the right use cases for serverless? Serverless is hot, right? It's something everyone's interested in talking about right now. And so then we over apply it sometimes. I think the reality is there's a lot of workloads that are not meant for serverless. If you have a very long running task, it's not meant for serverless. If you need a lot of resources, high memory, lots of disk space, serverless is probably not a great approach. And if you have already a very sophisticated process, you're running Kubernetes, you've got a mature DevOps or SRE program, you're already great at delivering at scale, serverless might not give you a ton of advantages, frankly. But what I think we find and what we see when we look around in the market is that there are a lot of really sophisticated large companies who haven't invested heavily in DevOps. It hasn't been a core competency for them. And by and large, they haven't needed to. Think about like Google, right? Google has needed to operate at scale. It's a core business differentiator for them. If you only index 1% of the internet, it's not super interesting, right? So they've needed to get very good at scale, and so you see projects coming out of Google like Kubernetes. And if you have Kubernetes caliber engineers and you're solving Google scale problems, I think that's a great approach. But then there's a huge chunk of the market, like most companies, 80-90% of the market, they're not really solving Google scale problems. They don't really need orchestration to be a key differentiator of their business. They want their product teams focusing on their product. They want to develop value for their customers. And this is where, if that feels like your team is saying, we're not shipping fast enough, we have a lot of deadlines, we need to improve velocity, then doubling down on orchestration, that's probably not going to unlock a lot of gains for you. If instead you can say, hey, we're going to ship that responsibility to the cloud provider. I don't care which cloud you use, Google, AWS, Microsoft, I promise you, they're good at this stuff. They're doing it well, they're hiring great engineers, and if I can offload that work to them, all the better for me. Because I'm a CEO. I want my team working on our product. delivering value for our customers. That's where we win as a business. We don't win as a business by being really, really good with Kubernetes. Now, that's our business. Some businesses actually do need that as a differentiator, as an advantage for them. And you know, I think that's a decision each team, each company is going to make. But the path forward for serverless typically is, do we already have a workflow, a pattern that's working very well for us, that allows us to deliver quickly, that allows us to deliver at scale? Is this a competency of ours? And if so, keep going down that path. You've got it working for you. But if you feel like you're struggling, like we are really slow to deliver, we really need to improve our reliability, our site performance, things like this, then it's probably time to start betting in a different direction.
Got it. That makes a ton of sense. So I have one more question, and then I hear you have something prepared to show us, so I'm excited for that. But I mentioned this to you just before the call, but I read, I think just yesterday, an interesting article about open source serverless packages to allow you to run serverless yourself. And your definition, if we go back to the beginning of the call, of serverless was, you know, that you're outsourcing the operation. So that feels like a weird intersection to me, and I'm curious, you know, what you know about these things and how you would think about that, if there is a class of customer for whom that makes sense, if it's about just separating the role of the, you know, your SRE team from the role of the development team. You know, what's driving that force or driving that demand in the market, I guess? Yeah,
so we're seeing a number of projects come out. Some of them are really, they're exciting. They're kind of cool. Open Fast, Fission, Function, Fusion. These open source projects that essentially run a fast layer, function as a service, on top of a Kubernetes deployment, right? And in some ways, clearly that fits the definition of serverless. It's like run my code on demand. And in some ways, I think it really, like, you know, raises some questions. I think of serverless as being a managed service for compute. I can outsource kind of running my compute instances. What's interesting, I think where we see this pattern working, is for companies that do have a very sophisticated architecture. They've got, you know, a mature program, they're running Kubernetes at scale, and they're thinking of it as a managed service for an internal user, right? So essentially you have one team fulfilling the infrastructure needs, the managed service needs of another team. And in that case, it really is still serverless, right? I can be an application team, a developer team that can consume these functions on demand without actually having to know how does that underlying infrastructure work. And it's this abstraction layer that I do think drives a lot of advantages. It drives velocity. We're seeing a pattern emerge. And what's interesting is I haven't seen like a consistent kind of coherent naming scheme for this. We hear people talking about like, we're developing a platform team or you know, some team that basically manages infrastructure behind the scenes and then exposes this really consistent interface for all of the product teams, right? It's almost like you could imagine like if we were going to build our own Heroku internally so that developers had this really easy experience, but we were still in control of our infrastructure, right? And that pattern, that there is a, you know, a function as a service component that can make a lot of sense there. But again, I would call out that if you're running a platform team, if you're great at Kubernetes, that might be a really useful pattern. If you're not there though, I don't know that that's the fastest route forward. I don't know that it's first get good at Kubernetes, then run your own, you know, fast layer, and then expose it to developers. I think the public cloud offerings, they're mature, they're stable, they're, you know, it's the best way to get velocity right now.
Yeah, that makes a ton of sense, and it really hits home for me. You know, we started in this business offering CI as a service in the cloud, and now we have customers running our stack internally, and our customer, our actual customer in most cases, running the system is that team. They might be called a platform team, engineering efficiency, developer tools. You're right, everybody has a different name for it. But that's the same group, right? They are a central small team creating leverage inside a larger organization by splitting the work, right? Taking on the thing that can be centrally managed to then allow the developers to focus on, on the business value, as you've talked about a number of times. Cool. Well, that was all very fascinating, and I've learned a ton again, and I'm talking to you not for the first time, so hopefully valuable for others. Now, as I said, I know that you put something together to show people, a little bit of how this works, and in particular how it works with CircleCI. So I'll give you an opportunity to talk through that for everyone, and then just as a reminder for folks, if you have questions, there's a Q&A icon, I think, down here. I always love pointing in these things. It's probably down there on your screen too. If you want to post some questions, I'll take a look at those now as Nate's talking through this brief demo, and then we'll take some time to answer them. All right, so jump right in.
Yeah, so I mean, real quick demo, like 5 or 6 minutes. Basically, we're talking about a lot of things that might be new. People haven't actually done it yet. And I thought it would just land it if you could kind of see a real world workflow. So I'm going to switch over to a screen share here, and I'll just step through and we'll do a real deployment using, Stackery and CircleCI. So this is the UI for Stackery, and I just want to call out there is a CLI, and that's how it works with Circle. So we'll actually get to see that too. But here's a little application, and basically what I have, this is running on AWS. I have an S3 bucket where I can upload images. I have a Lambda function that will read these images and then resize them and drop them in a processed image bucket. So first thing I'm going to want to do is I'm going to want to introduce a new change. Now, normally you would do this through an IDE, but just for demo purposes, I'm going to come in here and I'm just going to say, I got my CircleCI demo. Here's my comment. I'll submit this. And now I have this new change. So the first thing that I'm going to do is I'm going to commit this to my version control. And I'll just say, demo comment here and save it. So in real time, what's happening is Stackery is connecting all of your tools together. So we can switch over to GitHub and we can look for the code for this function. Here it is, and we'll see in real time now I've got my new comments. So Stackery has kind of tied the pieces together, but then Circle is actually going to manage the whole release process. And you'll see it's already started. So just by doing that PR, we've got a job kicked off. And we've got this all configured. The CircleCI configuration is right here in our version control. Our stack, the description of that architecture is right here in version control. So we have one place that has my complete architecture, my pipeline, and all my code, so that the whole team's working off the same kind of standard system here. So let's jump in and kind of take a look at what's happening here. We'll have a workflow for this release. And if we come look at it, you can see we started off, we ran our unit tests. Now we're deploying Stackery. And what's happening here is we're going to deploy this out to a staging environment. So we can actually see it's happening here. Here's the Stackery CLI being run by Circle. And the two products are really closely integrated. So if I switch over to my staging environment, I'll be able to see here in just a second that Stackery's actually noticed that Circle has prepared this deployment for me. So these things work back and forth together, and now it sees that Circle's actually executing that deployment. So what's happening under the covers is this function's getting pulled out of GitHub. It's getting built with all of the dependencies, uploaded into the AWS account, and Stackery's described this architecture using CloudFormation. So it just went through the normal release cycle that your ops team's probably already using. We jump over here to deployments. We can see now that this change is now live in our AWS account. And again, we come back to the workflow and we can see this is all happening exactly as expected. So it ran that deployment. Now it's running through all of my integration tests. This has historically been one of the hardest parts about serverless development is you want to run these tests, which means you've got to be able to quickly provision a new instance of the application. And so in this case, any developer can trigger this, kick it off just with a PR, and we've got this up and running. And now finally it passed all those integration tests. And so now we're gonna start deploying the production version. So again, we come back to Stackery here. We're gonna switch from staging to production. And again, we see that it's preparing the deployment now. We can watch it go through in either tool. And we'll see we've got it all integrated and running really, really quickly. I mean, we just went from, you know, my development change to now deploying in production in just a few minutes here, including running through all my unit tests, all my integration tests, and all managed out of a centralized repository. So anybody on my team can do this. So we'll come back here, we'll give it just a second. It's gonna release this change, and then we'll jump over as soon as this deployment's finished. We're just waiting for AWS to finish executing all of our changes. And as soon as this is done, we'll be able to upload an image and resize it automatically. We'll take a look at that.
Well, while we wait, there's one, I'll take the question, and then if anyone has any more, feel free to throw them in now based on this. Otherwise, I'll come back with some more. But I know you've talked about this a little bit, and I think it's a great way of phrasing the question. But who shouldn't use serverless? Like, what are the bad use cases? The places where, you know, you talked about over-applying. Earlier this year, I was publicly joking about over-applying AI, and just how, you know, same kind of cycle. Everyone is just, oh, we have to have this. And so people are putting it in places that it doesn't belong. So what are those places for serverless in your mind?
Yeah, so one of the big ones is a long-running and very predictable workload. So if you have a workload that, like, every day you have a 3-hour batch job and you're good at, like, spinning up a server, running that, and then shutting it down, like, that's probably, frankly, a better solution. Now, if you can break that workload up into little components, serverless is really cool because you can parallelize a lot of workloads. But things that are, things that are long running, and a good example, I mean, I used to work on the data science team at GitHub. We had a lot of jobs there that were like very, very large amounts of data, lots of compute resources required, and we were triggering them on demand. So, like, we could predict and anticipate when the workload was going to come through. And that's a great instance for having long-lived stateful infrastructure. But if you can't predict the volume, serverless is really good. If you're doing these kind of small little transactional workloads, serverless is really good.
So I don't know if we're ready yet, but as an extension of that, I mean, one of the things that came to my head, and at first I thought I was going to be joking, but now I'm kind of curious because we talked about, you know, serverless stacks that you can take and employ yourself. But I think about embedded systems, right?
Yeah.
Or sort of these places that a lot of us are forgetting. But, like, speaking of hype IoT, you know, people are building things into really small devices. Do you foresee a world where on those platforms we're able to really separate ourselves? Like, I still assume everyone writes a lot of that stuff in C and C++, and it's really low level, but that's not always true. Do you see a world where we could actually create this kind of separation similarly and isolate ourselves from the complexity of those systems?
Yeah, I mean, IoT is actually a really powerful use case for serverless. You've got all these devices that are going to phone home, and like you don't know when you're going to get this load. But a great example is iRobot. They make the Roombas. They have a huge serverless backend, right? They have millions of robots that all are going to send data up at, whenever they want. And so you get this really bursty traffic, and you want to scale your backend to support it. A failure there can be really obvious to your customers. And so, serverless does that. It scales up very well, but it also scales down very well. Because you're not running all of these servers with extra capacity 24 hours a day, you drive your costs down, which means you can reduce the cost of your products and win even more customers. So I think there are cases there. But the other side of this is like, where does the compute need to happen? One of the ones I think about a lot is like self-driving cars. Compute has to happen very, very quickly there. Mm-hmm. You're gonna, take a video and react immediately. You don't want to be shipping that data to the cloud. Like there are going to be these use cases that are real time enough that we need to make sure that compute becomes a commodity. We can run it anywhere, but when possible, let's ship our compute workload to the cloud and run it, efficiently, low cost, on demand, and at the scale that we need, and only pay for exactly that scale.
Cool. I want to get back to your demo, but
yeah, go for it.
The next question seems super related. I think this is a big part of the confusion. You talked about the naming of serverless, like people getting their head around, is it the right thing for my app? Like, can I even try it for my application? So the next one is it only for these light services and applications and crons? And in particular, you talked about these big batch jobs and then being able to break them down and parallelize. And so the question goes on to ask, if I'm doing something with multiple steps, et cetera, I want to paraphrase a little bit, but how do I manage the state? Meaning I've done a bit of work and that's created some output. If I spin that down and spin something else up, do I have these long startup times and wait periods, or are there effective strategies for managing, transitioning that data through these different functions, if you will?
Yeah, I mean, so first off, let's be explicit. Serverless is officially stateless, right? You're going to have this instance. It's going to spin up. It's going to execute. It's going to shut down. At least in theory, there's no state passing from one instance to the next, which means state becomes intentional. If you want to save something, you put it in a database. The reality is that while that is absolutely true, that's how we've been building apps forever. Like, I don't assume that I'm going to have data on this server necessarily. If it's something that I need to store and reference later, I put it in a database. I put it in Redis or something. Like, I make it available to the rest of my system. And so in this way, it doesn't really change. The typical pattern you're going to see, you get some event, some input message. It's going to trigger your workload. You're going to pick it up with a Lambda, do some processing, store that data. Maybe it's going in a Dynamo table. Maybe it's going in an RDS database. And then you can start other workloads off of that. What's really cool is that every step of this is an event that Lambda can react to. So you update the Dynamo table, another Lambda can be listening for updates on the Dynamo table. So like you can actually pipeline through like this workflow that you're describing. That's a great use case for serverless. I think that the big difference here, and the thing you're going to want to think about is you have to plan for this, and there's probably some data that you're going to want to save for at least for some workflows that you haven't thought about before. A really common pattern is I'm going to take Lambda and I'm going to read off of a stream. So AWS has a great managed service called Kinesis. It's just a stream. And the challenge here is you have Lambda reading off the stream. If that Lambda fails, that message won't ever get pulled off the stream. And so you get into these situations where like you actually want to store some data about like what workloads you're attempting to produce, what workloads are erroring, so that you can actually manage that failure and handle it and respond to it automatically. So in this case, you might actually write a pattern that's like Lambda's going to spin up. It's going to log a little message into Dynamo that says I'm starting this task, and then when it's complete, it's going to log a message that says I completed successfully. And that way, you do have a record that says like here's the workload that we're accomplishing, and here's what's getting stuck or failing. There is a service on AWS side called step functions, which actually lets you build these little statements. But it ends up being pretty cost prohibitive if you're trying to use it at scale. So generally speaking, it's relatively simple to build your own state machine where you just cobble together some kind of data store and Lambda. If you have workloads that are struggling on Lambda, you can also spin up similar serverless-like environments that are Docker-based with services like Fargate, for example, where you can trigger a longer-lived workload.
Yeah. So
go ahead.
I'm really glad that you brought up Kinesis in there. I mean, Kafka, speaking of things that people love to talk about, similar model. And I do think you mentioned, use the word pipeline in there. Again, going back to the fact that we are a functional shop, like this is where it does really tie into the model of functional programming in my mind. We think about a lot of our software as taking a chunk of data and running it through a pipeline of functions And we do that in the very small, within one function is just a composition of a bunch of other functions, which is just transforming data. And I'm trying to avoid all the nerdy functional programming words that scare people away from it. But if you're interested in this subject, understanding functional programming, if you've used MapReduce and Hadoop, like this is a similar kind of model that came out of functional programming. So I think there's some really interesting models in there that allow you to reshape your thinking in a way that's really good. And going back to my point of forcing us to do the things we always should have done, the great thing about that, if you're thinking about simple transforms on pipeline data where the pipeline is not ephemeral, where I consider all servers to be ephemeral, then you actually end up with a much better operational system where the loss of one of your systems is kind of who cares? Like the thing's going to keep going. Every job that I expected to get processed gets processed. So that's a really cool, but I really want to let you get back to your demo now.
I'll switch back over. One more comment on that, just to add a little color. So you can build, you can use a kind of a functional programming paradigm. But I don't let that scare you away. I think if you're familiar with that, serverless is an easy natural fit. If you're not, you can build a very traditional application, object-oriented programming, typical request response loop. I'm talking about responding to events. An event can be as simple as an API request. So you can get a request, run your code, respond back, and it's done. And in that format, it's going to look very similar to what you're doing today. There are definitely some new patterns you can adopt, but I don't want you to think like you have to go down this like functional route or evented route to be successful. We've taken totally normal like API paradigms, applied them to serverless, and had a lot of success with that.
Yeah, thanks. That's a really great clarification. I just get excited about all these subjects. I want to figure out how they all fit together. That was a really great question.
So I'm going to jump back here real quick. So here's one of the things, and this is not super obvious, but if we're spinning up these new instances of the application, so that we can test, we can run our integration tests, you end up with these resources that are really dynamic, and you don't necessarily know where things are in your account. So one of the things Stackery does, just to tie this all back, is we let you jump into a resource and then quickly hotlink into AWS, into your account, your console, so that you can see this resource. So I just clicked on this upload images. This is what's going to trigger my workflow. And now I'm inside of this S3 bucket. And so for fun, I'm going to we're going to run this. I'll do an upload here. There we go. Drop in a file. I've got a World Cup image, which is very timely.
No spoilers. It better not have a score in it.
It doesn't. Nothing like that. It's a logo. So here it is. So I've uploaded this image. You can see the size of it. And what we're going to do, again, keep in mind, that's going to trigger this function to run. It's going to resize this image, and it's going to drop this into another bucket. So to make sure that this happened, we'll jump into this other bucket. And here you go. We just got it. Resized. You can see the size is now smaller. We'll click on this and download it. And here we go. Now we have our new image. So I think this is not opening within my
browser. It's on the browser.
Same thing. So it was really quick, as you can see, using Circle. I made a development change. That's all I had to do. I merged that into master, and that triggered my entire release cycle. It spun up an instance of the application, ran my unit tests, ran my integration tests, and then moved everything over, re-released into production. And you can see that, all of that was automated. It took a couple of minutes, and I have my change live and working now.
Fantastic. Well, thank you very much for putting that together. I don't see any additional questions. We're actually running pretty deep on our time here. So thanks everyone for joining today. Thank you, Nate, for joining and teaching us all a little bit more about serverless and how we can get started and where to apply it in our day-to-day. And with that, I think we're good to wrap up.
Awesome. Thanks so much for having me. I really enjoyed it.
Great.
All right.
Thank you.
Bye.